are going over sequences and word problems. We've got to figure out if things are the arithmetic sequence or a geometric sequence. Remember, arithmetic sequence are things are being added or subtracted. Geometric things are just going to be multiplied by a number. Okay? So right now, something you need to think about is the two different formulas. Right here for arithmetic sequence, you can put in your journal. Ready? Put A, N equals the very first term plus N minus 1 times D, which is the common difference. The number that's either being added to or subtracted from. Geometric sequence, A-N equals A1 times R, which is our common factor that's being multiplied to the power of N minus 1. So we're trying to figure out, are we going to use this formula or are we going to be using this formula? So those are the two formulas that we're going to be applying in this particular set of assignments, the problems. All right, so it says, Jacob is a teacher. He made 75 cookies to give to the students on the first day of school. He gave 2 cookies to each student who showed up for class. Let G of N be the remaining number of cookies Jacob had before the nth student arrived. Okay? So right now, what's happening? He's giving 2 cookies to every single student. Okay? So he's giving 2 cookies per student. So obviously his cookie supply is going down. Okay? So this right here would be an arithmetic sequence. It's going down by 2. So we're going to write right now. We're going to write A of N equals, and this right here, this is what he started with. He started with 75 cookies. 75. And then I'm going to put minus 2 times N minus 1. Now you could have also done this. You could have also done 75 plus N minus 1 times a negative 2. Well, what's the negative 2 represent? That's our common difference. So if you plug in a 1, those two, right? You plug in a 1 right here, we're going to be basically having, we have 75, but it's going to be going down by 2 each time. So he's starting with 75, working his way down. All right, so this is an arithmetic sequence. We're going to go down here. All right, so right here, this is a little bit different here. Okay, it has G of 1. All right, so basically right now, you plug in a 75. Now, everybody, I'm going to stop something real quick. I want you guys to write this down. Right here, this part, right there, that means the previous number. So let me write. Stupid board. We'll put previous term. Okay? So that G parentheses N minus 1 represents the previous term. Now, right here, you see where it says plus or multiply? You're going to put plus, but we're not adding a positive, we're actually adding a negative. So what I'm going to do right here is I'm typing in 71, sorry, not 75. That's my A1. And I'm going down by 2. So this would be my final answer. The previous term minus 2. So every single time you get a previous term, you're just going to take away 2. Start with 75, then 73, then 71, and so on and so forth. So I'm going to put right here, I'm going to put plus. But I'm actually going to type in a negative 2 because he's giving the cookies away. Okay. So there, right there is your final answer. All right, moving on. Here's our new problem. All right. I wish I knew how to pronounce that person's name. We'll say Wanatan. Purified a portion of water with 900 grams of contaminants. Each hour, a third of the contaminants was filtered out. This is going to be important. A third of the contaminants was filtered out, but 1/3 is filtered. 1/3 is filtered, how much is remaining? If there's contaminants, how much is going to be remaining? 2/3. That's going to be important in this problem, okay? This number, things are being multiplied this time. So this is definitely going to be a geometric sequence in this problem. Okay? So it says let G of n be the amount of contaminants in grams that remain by the beginning of the nth hour. Okay, so by the beginning of the nth hour. So we're going to write right here. G of n equals, now what did we start with? We start with 900 grams of contaminants. That's like a lot of contaminants. That's what we're starting with. So that right there, that's our beginning, that's our A1. Now, this is where it gets a little tricky. If you are basically taking out 1/3, what's still remaining? Total of 2/3. So if you multiply something by 2/3, you actually lose 1/3. Okay, so this is where students might plug in 1/3 and accidentally get it wrong. And then you're going to put n minus 1. Now, how could you check your answer in the graphing calculator? Here's what we could do. Does everybody understand if you start with 900 and you lose 1/3, what does that mean? You lose 1/3 and you multiply that by 1/3, you lose 300. So what should the next term be? It should be 600. Right? And if you take 600 and you multiply it by 1/3, you get down to, how much do you lose? 200, and that would get you down to, you lose this amount, so it gets you down to this amount. So you go to your graphing calculator, all right? See if I can find it right here. And we're going to type this in to see if it makes sense to us. So we're going to go to y equals, if you would. Go to y equals. I'm going to clear this out. We're going to start with 900. We're going to open up the parentheses, do 2 divided by 3 to the power of x minus 1. So 900, there's our first term. There's our r value to the power of x minus 1. Now I'm going to check my table. Right here, what are we starting with? We're starting with 900, then we're going down to 600, then 400, and it keeps going down. What are we losing? We're losing 1/3, but we're keeping 2/3. So what we're going to do right now, I'm going to write this formula in right here. That's the formula that I'm going to write in, and it's a geometric sequence. All right, so it's geometric. Do 900. Parentheses, 2 divided by 3. Power. Now this is where it gets a little tricky. I gotta use this minus sign here to keep it up top. Otherwise, what happens is if I use the minus sign on the keyboard, it brings it down. We don't want to do that. Okay, so make sure you use the minus sign that's on the keyboard for the Khan Academy in order for that to get to work. Okay. All right, here we go. Got 2 more problems to do, and that's it. So it says Muhammad decided to track the number of leaves on the tree in his backyard each year. The first year there were 500 leaves. Each year thereafter, the number of leaves was 40%. The keyword 40%. More than the year before. All right. So right now we're increasing it by 40% every single year. So if you have 100% and you are increasing it by 40%, now you're at 140%. Okay? Now as a decimal, all you always have to do is just take your percentage, divide it by 100, and that will always give you your decimal. If you forget the whole which way to move the decimal. Just know that the decimal for 140% is 1.40, also known as 1.4. That's how you increase something by 40% every single year. This is going to be your R value. That's it. It'll be immortalized now, forever. All right, so right here, this is our R value. That's our common rate. All right. So right now, this is definitely geometric. All right, and our formula is going to be, if I said what is our formula, I'll put f of n equals our initial value. So the first year he started out with 500 leaves. We're going to multiply this. So I'm going to put, instead of a dot, I'm just going to put parentheses. Put 1.4 to the power of n minus 1. So that's going to be, if I wanted to write an explicit formula, that would be the formula that goes with this given situation. Now, what they're asking us is a little bit different. Okay? So right here. So right here it says f of 1. What is f of 1 equal to? It's going to be 500. Now here, we're not adding, I'm going to put that little dot, we're going to be multiplying. Right? But what's our R value that we're going to be multiplying every single thing by? 1.4. So 1.4. So this time I didn't have to write the formula. I'm writing the formula down for you guys to write down in your journal. Okay? But all we need to do on this one is do a 500, we do a multiplication, and we do 1.4. Now what I'm going to do is I'm going to change colors here. And what if it wasn't more than? I'm doing a what if, okay, for our journal. What if it was 40% less? Yeah. So if it's 40% less, then I got to do what? 100% minus 40%, which leaves us with 60%, and that decimal is 0.6. So if it wasn't more than, if it was less than every single year, then this number would change from a 1.4 to a 0.6. And here I'd still say multiply, but I would change 1.4 to 0.6. And that would be your answer. Okay? So this is the what if situation. Let's go ahead and type this in. Okay? So right here, we're going to start with 500 leaves. We are going to go here, we're going to say multiply, and we're multiplying it by 1.4. Okay, it's not the same. Oh, you're right, it's geometric. There we go, thank you. So yes, it is geometric. Alright, last one. Here we go. Chinadu sat down to do his homework, which included 30 math problems. He solved 2 problems each minute. Let f of n be the number of problems left for Chinadu to solve at the beginning of the infinite. Okay, so he starts with 30, and he works through a minute. What's it go down to? How many problems does he have left? 28, right? And then he goes down to 26, then 24. So what kind of sequence is this? Is this arithmetic or geometric? Arithmetic, okay? So right now, I'm going to put f of n equals, we're starting at 30, so that's my first term, okay? But we're going to be going down by 2 for every term thereafter, okay? So right here, this is going to be my formula right there, because he's solving 2. So that means how many problems he has left. Now, if the problem said he's solving 2 problems each minute, how many problems did he do after, like, let's say he already solved 30 problems. If he already solved 30 problems, how many more problems did he do? Then you would say 30 plus 2n minus 1. If it said he already solved 2 problems and he continues to solve problems, like you're adding to it. Okay, but here we're trying to find how many problems he has left. So this is going to be the formula that I plug in. So it's arithmetic, and here's the formula. So it's arithmetic. It starts with 30. It's going down by 2 for every problem thereafter. Okay. There you go. That's what you're doing right now. Still recording. I can't get it to stop. Please, get this thing to stop. Somebody. There we go. All right.